Hashicorp Vault learning series point of view. Seventh topic is Transit Secret Engine. So I am in a Hashicorp certification page, Vault Associate. So if you scroll down the syllabus, so the fifth topic is compare and configure Vault secret engines. Choose a secret method based on the use case, dynamic secret versus static secrets, define transit engine, define secret engine. So in the previous session we have discussed the secret engines and dynamic secrets such as AWS or database, static secrets as a key value pair, etc. And here is only the new topic is a transit engine, which is important with respect to this chapter. So transit secret engine. So as we know, Vault has a Vault core engine and which has a storage layer where you can configure the internal and external storages, and also Vault offers a variety of secret engines, and also Vault provides authentication and authorization in the form of a policies, so where you can connect various authentication systems, and also Vault provides audit. So secret engines point of view, these are the secret engines. There are many, but whereas the point is authentication method, whereas you will apply a policies to access a specific secret. That's what we learned from the previous sessions. So if you look at the secret engine, there are many secret engines here, and in fact if you go to the Vault homepage right here, and there are many secret engines here, right? Out of the many secret engines, there is a secret engine called a transit. That's what today we are going to learn. If we look back the Vault secret engine lifecycle, so you can enable, you can disable, you can tune it, or you can move its secret engine path with the various versions. So that's what we learn. Today's topic is transit secret engine. So if you try to create or enable a secret engine, you will end up seeing this transit secret engine. So this is my Vault server where I will log in with my root token. This is my root token. I'll just copy and paste it here, right? So and create a new engine. So here is the Vault secret engine where you will be able to see this particular secret engine. So what exactly this transit secret engine? So transit secret engine, as a name suggests, transit means between the journey, during the transit. So we will be applying a cryptographic functions of data, means in the transit the data will transfer from source to destination. So here cryptographic function will apply, and during this transit engine Vault does not store any data. It will generate and send it to the secret engine, right? So and this is called during the in transit it will apply a cryptographic function and send it. That's called a cryptography as a service or encryption as a service as per the documentation from the Vault. Now by using this transit engine you can sign and verify the data during the in transit. So by using what? Hash and HMAC. So HMAC means there is a meaning HMAC. So if you go to the Google HMAC meaning, right? So HMAC means hash based message authentication code. So if you take an example, let's say there is an application which has a data and there is another application which wanted to use. So Vault is located in the centrally, and that will basically provides the encryption service and send it to the application, and this application will send it to the Vault. Vault will generate encryption key, and whereas the other application will use by using a ciphertext. So basically it's what the point is, Vault will centrally manage the encryption rather than developers point of view. It will be easy. Developer need not to worry about what encryption key we have to use, what encryption key we have to decrypt, and all these things, right? So here the Vault will manage. So how it is means by using an encryption key. Encryption key will be provided by the Vault, it will maintain it encryption. That's what the in transit. So why, by using this, what is the benefit is basically encryption and decryption. There is no burden, there is no hassle for the developer, because Vault will provide. Just developer has to use the whatever the Vault given a ciphertext to decrypt. So that we will see in a further slide, right? And by using this particular keys in transit point of view, so that keys you can maintain a versions, you can rotate it, and you can rewrap, like you can regenerate and all with the different version. So if you look at the transit engine use case, say these are the applications and these are the separate databases. So if they wanted to use, right, so each application has to use one encryption key, right, and have to communicate. That's a challenge. But whereas when it comes to the vault, which is centrally located, right, so this vault will provide us, this will manage the various databases these application will use. So these Java, .NET, or maybe Node.js, any applications, they can communicate to the basically the vault system, and this vault system will provide to the application. And in transit and the rest, at the both the places, this data will be encrypted. At rest means at the vault database level and as well as the in transit level as well, right? So transit engine point of view, as we have seen the keys, right? So here the keys. So those keys are the various types as per the documentation. So these are the various keys, whereas you can apply different types of algorithms for the your use case. So these are for the only for the transit point of view. So Vault also offering a convergent encryption as per the documentation. What happens is, as per the convergent algorithm, so your plain text and the context of the key will generate a ciphertext. That ciphertext is used to decrypt to back to plain text. So that's what it happens. It works. And by using this, basically it's a stored encrypted in the database. So you are not directly storing the data, you are storing it, you are converting as encrypted at the client side, and only you will be giving the ciphertext only. That ciphertext will be stored there with some other encryption. So as a multi layers of encryption will be happen internally, like a data key also will be there internally, right? And this particular algorithm has multiple versions, version 1, version 2, version 3, whereas each version has it's there. I think it's version 2 is currently in use, so need not too much go deeper into this convergent algorithm, just for the theory point of view. Yeah, so Vault transit engine point of view, there is a life cycle point of view. Yeah, one is enable. You have to enable like a same like a Vault secret enable, AWS Vault secret database enable. And whereas second step is you have to write the encryption key. So after once you enable the transit, the first step is you have to create encryption key. Then after that you will be encrypting the plain text with this key. Then after that the target system will decrypt using the whatever the ciphertext generated in this step. Then after that, if it is a keys is enough, maybe you can rotate per monthly or weekly or daily, depend on your use case. And there is a rewrap. Also Vault transit engine has a functionality where you can generate a new version of a key. These of the options may be asked in the examination. So encryption as a service for the transit engine. So how it works is, so Vault will centrally manages this particular encryption as a service. So let's say this is application and this is application and wanted to send the data securely, which Vault, this application will have a data which is encrypted, either stored in a Vault or any other database, this application specific data. And so Vault, what it will does is centrally manages and it will applies the encryption as a service. So encryption will be the service for both the parties. So application send the data to Vault and have it encrypted. so this application. Then vault decrypt the encrypted data for the application to use. So this guy is basically is doing this particular service as a transit, how we will see in the demo, short demo. So right, this is the in short. This, by the way, this particular all the images which I am showing I have taken from the vault documentation, so need not to worry or need not to take a screenshot or anything, right? All the key tabs are over here, right? So everything which is there from official documentation. So now let's have a quick demo. Yeah, so now the demo point of view, so let's take a vault server first. So this is my vault server, right? I have provisioned a vault server by using this particular Vagrant, right? So which is will uses Ubuntu latest version and provides as per the official documentation. So I have logged in already. So vault secrets list, so these are the secrets I have enabled. And if you go to the UI, right, so just go to secrets. So these are the secrets are enabled, right? Now the first step, enable the transit secret engine. So how to enable? So it's a very simple here, right? So here AWS enabled Cubbyhole database, GVR is a key value identity, and there is a key value I storing MySQL and system specific. So now if I wanted to enable vault secrets, right, enable transit. So when I do that, basically transit secret engine is enabled already. So if I go to the UI and just refresh, this transit engine is enabled. Of course I can enable from the UI as well, but the better practice is to by using this. So here the encryption key is not created. Get started with the transit. So you will need to create an encryption key, that's what it's saying. So as a second step, create an encryption key. Yeah, encryption key means keyring, right? How you will create, right? Go to the right here. So vault, so how to write and space -f. So in order to create, say before that, let's do one thing. So vault secrets list. So when I do that secrets list, this is a transit secret engine type, and what is the path? Transit. So now what I am doing is vault write -f, then transit /keys hyphen, I have to give some key name. So say test key, right? So test key I will put. So now the test key has been created in the vault. So if you go to the UI, right, and go back and just go and click here again, the test key is got created, right? So instead of creating from the UI, you can create a multiple keys here, but I just created here, right? Now, so now the next step, go to the slide and encrypt the plain text using this key. So in order to do that, so vault write transit, this is a path, of course, this is a transit, and /encrypt. So here what is the major step is we are doing encryption here in the step 3. So transit is a path /encrypt. What I am doing encryption, test -key, right, and plain text equals to $. So you cannot give like a test 1 2 3. So vault accept base 64 encoded string. So how to encode the base 64? Echo test 1 2 3, right, graph and base 64. This is the way it will encrypt. So when I click enter, so vault write, so what I am doing is in the transit layer I am encrypting with this key, the above generated test key. So maybe this key, what is the key content and all, you won't be able to see, right? That is internally there, but it uses this algorithm AES 256 GCM 996, which you can just go and just search it here. This is the what the algorithm which uses. You can change the various key types by using its internal options. Just you can restrict the deletion also. Yeah, here the overall the point is, whenever after creating a key, I am encrypt by using my created key plain text of the base 64 encryption. So it doesn't accept the direct one. So now what happened is immediately it's created a ciphertext, right? So now decrypt with the ciphertext. So now this is the ciphertext. So you see vault v1. So in the one of the slides we have seen that vault v1, v2, v3, right? If you go to the documentation, right, scroll down. Yeah, so convergent encryption version 1, version 2, version 3. So each has its own significance. So this is the what the ciphertext basically, right? So now how to, once it is done, then we have to decrypt it, right? So that's what the next step. So how to decrypt vault, vault. So write, then transit instead of encrypt, so decrypt. This is the one of the API which is by the, so test hyphen key, right, and ci ciphertext equal to ciphertext and ciphertext equal to, so this is the key you need to pass. Maybe you have to, you can just put it in a one variable and pass it, however the way you do the automation. So whenever I do this, so I got the plain text back. So means like you will be, vault will share the this particular to the client application. So this one is a very simple how to do that, right? So echo and this guy, then is a simple base 64 decoding, right? Oops. So echo base 64 hyphen d. So this will decrypt back to text 1, 2, 3. So in this way basically you can first create a key, encrypt and the decrypt. Now the decode and use, yeah, that's what we decoded and use. Of course you can do the here itself, just you can do this way and just base 64, if you are Linux master you can do then and there itself. But yeah, there is a way, it's not work like that. You need to extract this value and in that way you have to do. Okay, but you get an idea, right? Now yeah, now then another step is basically where we can rotate, rewrap, right? So let's see that. So how to rotate? So vault, right, transit, right, and what we are going to rotate, keys slash. So if you go to scroll up, keys, so this is the path I am taking, right? So so just let's copy this test key slash rotate. So when I say, oops, rotate, oh sorry, hyphen f is missing. So in order to rotate it requires a slash f. So now the key has been rotated. Now the next step is rewrap. So how to rewrap? So vault, right, transit. So after the transit, so if you observe here, if it is any of the functionality like a encrypt or decrypt, after transit there is encrypt. So after transit, so rewrap. So all these commands are available. Rewrap of what? My test key, right, and cipher ciphertext equal to, so I have to pass the old ciphertext which is this one, right? So right, so what I am doing is whatever this particular ciphertext, by using this ciphertext I am rewrapping the key. So when I press enter, it's given me the another ciphertext with the version is 2. So means like here what we have done, here we encrypted the first time and it given the ciphertext, and with that ciphertext we decrypted with the version 1. So here during the rewrap, which is the same kind of a encryption functionality happened, but the thing is a new version of key has created. So let's, if I say if I copy this, right, decryption functionality and copy and decrypt and using this version 2, oops, paste it, then again I got the same value as this, right? So right, this one. So now echo again the same value, then I will get a test 1, 2, 3. So this is the what the functionality of not only these 5 but also rewrap, and as well as also if you go to the documentation under the secret engines and transit, so there is an examples are given use as well, right? So basically rotate, rewrap, and how you will be able to do. So this is the way. And if you go to the UI, right, go to the transit, right, so you will be able to, in the details and versions, you will be able to see the multiple versions. So you can create a multiple versions and manage the in transit encryption. So but this is the only this key, right, the whatever the key we created, which is a in transit key. But in actually in the vault system wise, we don't know that, we won't be able to see. But vault write -f transit, right, transit. So we use the keys, right, instead of keys, data key, right, and plain text /test -key. So what exactly this mean is, so this is the in transit key, but this in transit key is covered with one data key which is actually stores in the vault database. Vault maintains this, we won't be able to see. But however, if you query, this is a data key is a API method, so that you will be able to see how the, but this plain text is not same as the other one. This is a vault internal specific data key. So if you go to the documentation, and you will be able to see generate the data key. So this is a data key at the data level. It's a encryption. This key actual the key one I created initially, it is encryption key. Yeah, that's it. So and you can do it by using a UI as well. Currently 2 versions are there, but UI is a pretty simple. You just go there and click. But only the thing is, we need to know the commands with respect to the exam or with respect to learning or whatever. And all the examples are here. And there is a vault learned at Hashicorp, where transit engine, there is a very good example is given. Also rewrapping, there is a real world some scenario. And also there is a Java application, how the Java application and it maintains this encryption, it's given. It's a very good details. Yeah, that's it for this particular session point of view. And here whatever the commands we put here, and need not to write down or note down or anything, it's there already here in the vaultproject.io. So all the commands are here, so no need to note down, right? Only the thing is to remember transit.keys, encrypt, decrypt, rewrap, data key. Data key is the data key, you can, right? So yeah, that's it. And I hope this session is useful, and this is a purely learning session. And if I miss or anything is to be added, feel free to comment. And thank you for watching. Bye bye. Please like, comment, share, subscribe. Bye.